Buckle up for AEC Trailblazers, the Founders Files, where we crack open the stories of the brightest minds in the AEC startup scene. Forget institutional pitches. We're diving deep into the real personal journeys of these industry disruptors. Get ready for some casual chats firsthand.
Hello, everybody, and welcome again to another episode of the AEC Trailblazers podcast, where we interview the most amazing founders on the AEC. Here with us, we have Jim Baldwin. Jim is a seasoned tech executive with more than 30 years of developing software and hardware experience. He's led teams at Apple, Microsoft, and Intel. As a serial entrepreneur, he founded Antimatter Research and Domanic, focused on consumer electronics and smart buildings, respectively. Jim is passionate about using technology to improve building efficiency, comfort, and safety. Hi, Jim. How's it going?
Really good. Good to be here.
Thanks for being here with us. I see you're in your office. Can you tell everybody where you're located?
We're based in Silicon Valley, in particular in San Mateo, California. So we've got a nice little office space downtown San Mateo, which is kind of well situated around the train and near lots of restaurants and cocktail bars and things like that. So it's a pretty great location.
Beautiful. I feel a little bit of jealousy of not being there. I love Silicon Valley. I used to live there. So every time someone who's a tech entrepreneur and lives there is like, I envy you. I envy you.
And I've been here a while. I don't even remember where I used to live before that. I do. I'm kidding. But
we will get into that. But can you tell us a little bit about yourself? Like, I know you're an engineer. Can you tell us how everything started? You always work on the AC, or you used to work for other industries in the past? How everything started for little Jim?
So probably the most interesting origin story about what we're doing at Domanic does go back to the beginning of my career. So I went to school in the Midwest. I graduated from U of I in Champaign, Urbana, and got a job at Apple right out of college. So I cut my teeth at Apple during the crazy days. It was kind of the period of time where Steve Jobs had left the company and he was off doing Next, but he hadn't come back yet. So I'd say Apple was kind of rudderless at the time, but at the same time, it was everybody there just wanted to do something fantastic, and it just had this culture of try anything. And as a kid straight out of college, for them to look at me and say, "Hey, we need to develop a chip for this thing we're trying to do to connect devices together. Can you make a chip?" I'm like, "Sure." "What do you need?" "Probably a computer or something." So it was kind of that nutty environment where they were just willing to invest in people and try things out. And I was able to, learn a ton of stuff working there. And we built stuff that it just be remarkable. Like the projects I worked on there spanned from a pen that you held in your hand, and we could measure its position and orientation with 6 degrees of freedom. Long story about why that didn't come to fruition, but I worked on a high-speed fiber networking project. And then ultimately the most interesting thing that came out of it, well, two interesting things that you probably know about today. One is that touchpad on your computer is a technology we brought in through my team at Apple. And I did a lot of the early research into how to make it work at scale. And then I worked on another technology that we called Firewire. And Firewire was this kind of a idea of what if we could put the power and data connection on a simple cable to connect computers to peripherals, because at the time the ways you connected peripherals to computers required really ugly cabling. It was complicated. You had to set dip switches to make sure the addresses were different, and you had to have IT skills, and you had to install drivers on your computer. It was really a mess. And we said, well, let's try to clean this up. So Firewire was all about unifying it behind a single slim, but in a way, I mean, Firewire and USB were kind of contemporaries. I like to think that they've merged together now. So Firewire and USB both went aimed at solving this problem of how to make it simple to connect things. So we went from requiring IT skills and driver installation to now being able to, plug a webcam in your computer and it just works. And that's really the future that was created by that project at Apple. And, in a way, what we're doing now reflects a lot of that. We felt like the complexity of putting technology into a building defeats most of the build teams. It adds too much complexity, too much cost, and often gets designed out of the project at the VE stage because it simply can't be perceived as affordable because it's always extra cost. So you always have to justify the extra cost of the automation in order to justify it. So what we're able to do now with Domatic is we're actually what we're able to do with Domanic now is we made it simpler to install a smart fixture in a building than it would be to do a traditional fixture. So faster, cheaper, simpler, less skilled labor required, everything across the board, anybody can do it. So it's not just installation, but anybody can fix a fixture as well. So we're at the point where when it comes to maintaining a building, it becomes a lot simpler.
I love it how you're basically doing what Steve Jobs said, right? Connecting the dots backwards. Like, I love how your first job, which it's impressive, like you work at Apple, your first job was working at Apple and working on this kind of amazing technology. And for sure now sounds obvious, like, hey, you plug a wire into your keyboard or webcam and everything gets connected. But I bet at that time it was a mess. Like,
yeah, at Apple we had a kind of a mantra that we have to bend the technology to people. Don't expect people to bend to technology. And and when I looked at the world of AEC, it just felt like we were still putting technology solutions out there that people had to become IT people to understand. And I feel like the opportunity to build something that's truly plug and play has been sitting there, but no one's really gone after it. I feel like that's our mission, is to make the world of AEC plug and play.
There is so much it can be done in the AC, and we're like computers. I feel it's a good analogy because like they started improving really fast. Like the first computer was, I don't know, let's say Turing or whatever, but it's no more than 100 years, right? Construction and electricity in construction has been here for so long, and we have been doing like the same things over and over again and nothing has changed in the last 100 years. Yeah, a little bit more of technology, but you have LEDs or whatever, but the wiring and everything is exactly the same.
Yeah,
like
Romex was created in the 1930s, and it's still how we run wire today.
It's just insane. And the thing is, like, the technology is there because computers and other industries are using the technology to improve what we do, and that's why I love what you guys are doing, because like it when you told me what you were doing, for me it was like, oh, this is so obvious, but at the same time it's such a great idea. Like, we should be doing this on every house, on every building, on every office, everywhere.
Yeah, that's our big and bold idea, is to really make this new world we want to imagine. We have to change how we do things. We can't incrementally add things to the way we wire buildings to affect this change. We have to fundamentally change how we approach it entirely.
And how I know that your job at Apple influenced you on what you're doing, but how did you come with the idea? You were already working on something related with this, and then the product started getting more complex and you started adding more features, or how everything started?
A few things come to mind. Well, so I've always been kind of an idle tinkerer when it comes to home automation stuff. And I've been watching the market and the things that you can do with, adding gadgets to your home to try to simplify things. And it's a story of, getting an Amazon with a glass of wine and saying, hey, I want to automate those lights. And then, you get everything, everything arrives in the boxes, you take it apart, you install it, and then somehow you become disappointed. And it just feels like the world of smart gadgets built for automation has been focused on that consumer aftermarket world that is really meant to address point solutions incrementally to solve the problem. And this is where, wireless technology is fine for that because, that's really all you got to go on. I looked at it and said, but what if you're building a new building? Are we telling people to use the same crap gadgets that are being sold on Amazon to do automation for a new building? And indeed, that is pretty much what happens. The expectation is that somehow new buildings are going to have Wi-Fi in them, and you're going to go through the same pain of setting it up. And no wonder it's not happening. If we're going to, we really fundamentally have to do something different than what we're doing today. And we said, what if you had a clean slate, blank sheet of paper? What would you do to make it easy to put into technology into a construction project? And we started there and we stayed there because we said we can't simply fall back to the kind of things that we're doing today.
Oh, then that makes sense. Also, because when you think about automating, like you said, all these gadgets, and they make it sound really easy, like just buy it and then connect it to Wi-Fi. It's never the case. It's never the case. It's not something that your mother or your grandmother typically will easily install. And it's never 100% reliable. That's the other thing, is like everybody wants to have everything connected without wires. But the reality is that it's not reliable. We still have meetings where it's like, can you hear me? Oh, you're breaking up a little bit. And that's going to happen for a long, long time.
Yeah. So the other part of my career that probably informed what we're doing now was I was at a company called Web TV that got bought by Microsoft. And at Microsoft, the big project I worked on that was interesting was this idea of building a television platform. So back then, you got TV from the cable company and you plumbed it into a set-top box that hooked up to your TV, and the cable company could give you television, but the phone company couldn't. And we said, well, we know something about digital video. So what if we could make a system that would make it possible to use an IP network to send video over an IP connection, the internet, if you will, so people could watch TV without having to have traditional broadband. And the phone company that had a broadband solution with DSL could also offer TV services. So we said that was the true opportunity. There was the phone companies really needed a way to offer television services, but they simply didn't have anything. So we set out to build a system that made it possible to have a full high quality television experience as defined in that era. To be clear, back then you had a 500 channel lineup on your cable company, right? That it's a different world today, and we always said, someday this idea of sending video over an IP network won't seem so exotic. And indeed, it no longer is. But at the time, nobody thought it was really possible. So we said, well, we can't just build a crappy streaming video platform. We had to do something that had the properties that people come to expect in terms of robustness and resilience and high reliability that they expect from television services. So we built a system that we called Media Room. And Media Room was sold to, I think, 30 different telcos around the world, and they offered television services on their IP broadband platforms, so they could offer TV services to their customers. And it had a pretty decent success. The truth is, we didn't need it forever. It was a stopgap while the world got used to the idea that maybe we should just ship video over the internet. And that's really where we ended up today. So all that work to deliver different TV over different means, whether it's coax or satellite services or IP television with private networks, all gave way to you just have an Apple TV box in your house and you watch streamed television over it on your broadband connection. That's really where we needed to go. But we built this system that allowed you to fill that gap in the parlance of what was needed at the time. But what was interesting about it is we had to meet all the same requirements that traditional TV systems had. We had to be at 5 nines reliability. We had to have a high level of security. So, I literally flew around the world and talked to content providers all over the world and showed them how our system worked and convinced them that we could secure their content. Because, man, if you think your bank cares about, securing your bank transactions, talk to HBO about securing delivery of a video stream to a set-top box. And there's some serious security concerns. And we were able to convince them that we could build a security system that would meet their bar. And on top of that, you simply couldn't have a day where TV didn't work because there was a bug or something. So we had to have a thorough regime of testing and development and reliability that it kind of was unprecedented at the time in the world of software. So that experience gave me a really strong feeling that you can put technology into an environment where it doesn't fail you because of some glitch. It can be made reliable if you put the right process around it, both from a testing and development regime as well as a security regime. And we successfully did that at Microsoft. And AT&T bought it and they called it UVerse for a number of years. So for about 10 to 15 years, if you had UVerse television, it ran the software I built at Microsoft. And I think that also informed my thinking around this idea that so if you go into the construction industry, they're not going to accept crappy gadgets that are designed just to solve one problem. They need something that's going to last, they need something that's going to survive the test of time. It needs to be something that is robust and solid and also truly set it and forget it. You can't have something that works until it doesn't, and suddenly people shrug their shoulders about why it's not working. So we have brought all that learning from developing the media room / UVerse platform into the AEC world to build something that has the same level of reliability that people came to expect there.
Oh, interesting. Like all your jobs are extremely interesting, and I love how they're related of what you're doing at Domatic nowadays. But how was for you going from, because you were working on amazing companies, right? And how was for you to decide, you know what, I'm going to create my own company. I'm going to create my own product. How did you decide doing that? Because you could have just stayed working on these amazing companies and not started your own thing. And what was the trigger for that?
So I'm going to try to answer this without making it sound like the companies I worked for had any flaws.
Okay. Well, they have. So you can.
So my last corporate gig was at Intel. I was vice president of the digital home group, and I was building technology, figuring out how to take the kind of technology Intel could create into the world of the home, whether it be television or other features. And we built some services around TV delivery and things like that, but it just felt like I had been doing the same thing over and over again. For me, it was I was doing more of what I had done at Microsoft, and I came to Microsoft I didn't apply to Microsoft. I was at a company that I went to a startup called WebTV. We got acquired, and that's how I ended up at Microsoft. And it was a lovely time at Microsoft. I spent 15 years there. I met with Bill Gates several times. I was really inspired by the way the company was run at the time, and I felt motivated to, there's something great about working in a big company where you can do big scale projects if the company's behind it. And when the CEO of the company says, Jim, we need to get into the living room, and he's willing to put the dollars behind it, you can do amazing, powerful things. And that is great. And I really enjoyed it. However, I came from a startup where there's something about a small company that is going to live or die by its own ability to succeed. That is an experience you cannot replicate at a large company. And I had been always eager to get back to that. So at some point, as Intel was kind of trying to decide if they were going to continue doing this project, I decided it was time to move on, and I set out to go build something new, and did some consulting for a while, but ended up through the process of doing a bunch of consulting projects, discovered this need in the AEC space to solve a problem that was just plaguing them, and that's really how we got to know this. And I think I'll also give some credit to my brother, who was a home builder for 30 years of his life. And, he was a bit of an inspiration that you could just decide you want to do something like go build homes on your own and do that. He, like me, he at some point quit working for a big company and decided to become his own construction company. And I was, that inspiration helped me think not just about, splitting off to do something on my own, but also that maybe this construction industry could use my help.
So it's a mix between the influence of what you have done, your brother representing to you the opportunity of the industry, and you loving pain. Because if you're already being in a startup and you want to create your own, it's painful, but it's a nice pain that it's like you said, you cannot replicate it on a large company. Like if you love that, like adrenaline that gives you that you can success by your own means, you against the world, the only way of doing it is on a startup. Yeah.
Yeah, I truly believe that is true. And as much as large companies try to have entrepreneurship programs and things like that, nothing is the same as if your success depends 100%. Nothing is the same as if let me try that again. Nothing is the same as when your success entirely depends on your own ability to execute.
Yeah. No, and even if you don't succeed, even if you fail, you're going to learn so much that is going to teach you so much for your next opportunity. So I'm with you on that.
Learning
absolutely.
is a lifelong process.
Yeah. It never ends. That's also the thing. And when, I don't know, I feel I've also been, used to work on large companies, and when you're working on a large company, you learn a lot. Sure, but it's different. Like you're limited to the position you have. When you have a startup, you have to do everything. You have to do everything, and there is so much pressure. I don't know. It's so different that I love it, even if it's painful most of the days. But it is true. And when did you start? Like, how many years have you been working on Domanic so far?
So the idea for Domanic germinated around 2018. That year, we did a project for a customer that I met through. I got to know Eric Migakowski, the founder of Pebble, pretty well, and he had a friend doing a startup that was coming up with a new way of doing construction. He was focused on a better way to do interiors. So his idea was to build a building without trying to embed all the wiring and plumbing into the walls, to think of it as a shell, and then have a sort of a raised floor, drop ceiling, raised wall approach to running all the wires and plumbing, so that all that stuff could be changed. Because apartment buildings especially they're recycled every 7 to 10 years or something like that. There's a normal cycle where they go in and renovate them to upgrade them or spruce them up. And the ability to do that flexibly, he saw as a valuable opportunity. And he wanted to take this to a broad cross-section of technologies for construction, but he started with interiors. So so Eric hooked me up with him. The guy's, it's a great guy. His name is Ben Ha, and the company is called Social Construct. And we worked with them on this project, and Ben said, I heard of this idea of low voltage, that if you keep things in this low voltage domain, the code requirements are simpler. And, so I read up on it. We got the code book and we studied it, and we realized that there was an opportunity to do something differently here. So what we did there is we actually built the system based on a technology called Power over Ethernet. So Power over Ethernet is what people use so that, you can put an IP camera on the end of an Ethernet cable and it can be powered on the same cable. As one of the creators of Firewire and effectively, progenitor of USB, the idea of power and data on the same cable appeals to me. So we built the system as an IP-based control plane on Ethernet cabling with PoE switches, and it works. It's that building is up and running. We support it with the software we built then. That core software and evolved to what we built at Domanic. But the one thing we did learn in the process was the PoE technology fell short when it came to making any improvement in the complexity and cost of the system. So rather than being something that's really cheaper than traditional means of wiring a building, the PoE switches and the cost of the labor needed to terminate Cat5 cables and all the extra cabling you need was just too much. And as engineers, we said, now wait a minute, what would we do if we had a blank sheet of paper? And that's where we said, let's find a new approach. So we basically, at that point in time, founded Domatic and started building this new approach based on a much simpler wiring scheme, fundamentally solving the problems that we encountered using the Power over Ethernet technology.
It's just so smart, because it's not just when you're thinking on connecting, LED light or something, you think just electricity. Why do I need data? But then if you have data, you can start controlling it, and you can map it, right? And you can even set different moods of the color of the LED light, or there is so much you can do. But maybe you can explain it better than me.
The paradox is that if you have data, you need less wire. With our system, because all of our switch, we've got one of our switches right here. This is a Domatic wall switch. It's got like holding it upside down. It has an indicator on the side and then an up-down paddle switch. Very simple, straightforward. Looks to me like any wall switch that you might buy. It's got just two conductors coming out of the back. It doesn't make or break a circuit. So its job isn't to control the flow of electricity directly. What these two wires do is it gives it just a small amount of power it needs. It's like less than a watt it needs to operate, but it communicates over this wire to the rest of the network. So when you tap a button on the switch, a message is sent out to the network, and which is received by the software running in our central controller that says, "Oh, you tapped up. What do we do?" So we look up in our software all the configuration. What do you do when you tap up? And then we do whatever that configuration says we should do at the time. And which all happens in an instant, obviously. So from your perspective, all you see is you tap the switch and the lights came on. But that means we didn't need where with traditional wiring, to be able to control the light fixture from a switch, you would need what they call a switch leg, which is a dedicated wire going from that switch to that light to control the flow of electricity to that light. And effectively, with the way AC power works, the only thing you can do to control the light is either have it on or off, effectively. So like with dimming, you can only do this thing called triac dimming, where they actually just kind of chop it differently to get different brightness levels, but it's very, very crude. So you don't need switch legs anymore. And if you want to have two switches that are coordinating, like on the opposite side of the room, to turn that light on or off from either location, you need what they call a three-way runner, which is an extra 3 conductor cable that is going between the switches so that that circuit can be made or broken from either location. It's incredibly crude. And then once you wired that in, you can't change it without opening the walls up. So with Domanic, when you tap that button, it sends a message out. That message can go do anything. So you don't need those extra wires that are dedicated for control. That goes away. And on top of that, with the smaller amount of smaller thickness of cable we need because it's a lower power system, we're removing about 93% of the copper from a typical installation. That's a massive amount of copper, and copper is actually not that cheap of a commodity anymore. So it just stands to reason that not only can we make it easier to wire, we can actually eliminate more wire than we would have than you would need for a normal installation.
That's so smart. I mean, you're gonna put wires anyway. Why not just first the wires that are cheaper, secondly safer, easier to install because the code is there's no so many laws that you need to follow because it's low voltage, and also sending data and making everything smart at the same time. And I also bet that if it is less than 1 watt or whatever, you can also have a battery. So if there is no electricity, you can just connect everything to a battery that can run for hours, just in case, right?
Well, when you talk about batteries, one of the things that we do there is typically in a especially in multifamily buildings, that you're required to have egress lighting when there's a power outage. We do that with one single device in the building. They typically call it an inverter, which means it's a battery that can, when called upon, it can generate an AC waveform to power things. So we have one battery inverter in the building that is powering our hub. And when we detect that we've lost power, in software, we reconfigure the lighting to have only the minimum egress components on, which means we don't need special lights. You don't need, you've ever seen those frog lights they have in the hallway? That those have batteries in them, so that that when the power goes out, the lights come on. That's extra cost. Those batteries have to be tested every month. Technically, in a building like that, the maintenance personnel is supposed to go around once a month and hit the button to test the batteries, as if they ever do. But, that goes away. We just, in our buildings, we use normal fixtures, and we just say, this one's going to be on, that one's going to be on, those are going to be off. And we test it. They pull the plug in the power. We go over to battery backup. Our system comes up and powers the egress pathways for the minimum of 90 minutes or 2 hours, depending on what the AHJ requires. And we're good to go. We were able to save a ton of cost on special fixtures that have batteries in them for egress lighting requirements.
That makes sense. I bet you could even control and check if the lights are working automatically on your hub.
Oh yeah,
right?
We know everything. We know exactly what current and voltage is going to the LED element. So if a light fixture is failing, we can tell you. We've talked about even like for some of our customers being able to, when we detect something has failed, we could have they get an alert telling them there's a fault in the system, and they could literally order a replacement fixture by clicking a button on their phone app. We haven't done that yet, but that is the kind of thing that is possible when you have a system like ours. And, we know every click, we know every movement. That data that we can generate from a building is an unprecedented opportunity to feed into the design of future buildings and feed into the operation of the building to know if the building is performing as expected. It's just hard to do that today because, back to my original point, you have to justify the added cost of adding automation to a building today, and it gets pruned down because it is so much more expensive. With Domatic, it's actually cheaper to install a Domatic system than it would be to install normal wiring. But compare that to the cost of an automated system, we're probably 50% cheaper on the electrical than a fully automated system would be.
Yeah, but then you're only considering the initial investment. But I bet, like, if you have something like this, you can turn off lights when nobody's on the building, or you can turn off lights if they're not needed and it's really late. Or, like, for me, it's just insane when you go, to downtown SF or downtown New York, and you see all the offices where nobody there and all the lights are on, and that's a huge amount of money that with a system like this would be really easy to automate.
Yeah,
and save a lot of money.
It's really not that hard but the key is getting the technology in there in the first place in a way that doesn't scare everyone off. It has to have the resiliency and robustness that people kind of expect. So you can't just put flimsy technology in to solve those problems. But the ability to add occupancy sensors means we can programmatically decide what's on and off at any given time. We do daylight harvesting as well. This is a Title 24 requirement in California, and other states require similar things. So with daylight harvesting, we measure the amount of ambient light coming in through a window. And based on the amount of ambient light, if there's more ambient light coming in through the window, we dim the lights more. And effectively, rather than overpowering and having more light than necessary in that part of the building, we're able to conserve energy that way. And that's, whether that's a big energy savings is less important than the fact that it's a Title 24 requirement. And to do that today, you have special gear that is specially designed to wire up an ambient light sensor to a light fixture and have them automatically talk to each other. And if you don't wire that up right, it doesn't work. With our system, we merely have the sensor as part of the system, and that data goes into the processing for the whole building. So the software that we build can now have access to all these data points, pull them together, and optimize the performance of the building. And that includes controlling HVAC systems. And this is where the energy savings really starts to come in. A typical building, just with smart HVAC controls, you can expect to save about 30% over a building that is not controlled by smart building software. So we're already talking about a 30% savings, and then when you start to bring even more data to bear, that savings just goes up.
It's just insane. And do you foresee this as being something that is going to be mostly for offices, hotels, like commercial, or you foresee this happening of people just installing this for a regular house, like a single family?
It's really a question of timing for us. We can support projects today in the one more time.
As many as you want.
Question again. I'm gonna start a refresh.
If you foresee this as being something that is going to be mostly for a commercial use, or also see this happening on residential, and I mean like small scales of residential as well. A single house or something like that.
Right. So technically, our technology works anywhere that power is needed. There's really nothing special about the type of building we're going into. Electricity goes down our wires, and the data communication goes down the wires, and the software can be written to control anything. So that would work for any type of building. That said, we focus on multifamily hotels, commercial projects where, the work we do for each project at the stage we're at gets more bang for the buck, if you will. So rather than doing all the work for a single family home, which would be net out one unit of product, we are able to do the work for 500 units in an apartment or 500 hotel rooms, where there's sort of more of a better model for benefiting from the automation. I do think a day will come when Domanic enabled fixtures will be available at Home Depot, and you'll be able to go buy your fixtures, come home, and plug them in yourself. That day will come, but it's not where we start. With something new like this, you have to start at the opportunities that are more scaled in order to build the success necessary to get to that future.
I foresee a future where Domatic is going to be on so many buildings and on the skyline that you're going to be able to even control multiple buildings at the same time, doing light show that buildings communicate with each other, or
Yeah,
you could do it technically.
I did something like that for Burning Man a few years ago. So yeah, definitely we've got an eye towards creating something like that in the future. But anything is possible once you have a software defined architecture, provided you do it with security in mind. We're very sensitive to the idea that this has to have multiple layers of security to defend against hacking. But with that in mind, it is so much more valuable to be able to write software to do these kind of controls rather than hardwiring everything. You're basically stuck with what you have if you hardwire.
Yeah, and also the fact that you're going to provide an API, right? So people are going to be able to customize it as well, right?
Yeah. So our hub that runs within the building, I can show you. Got one right here.
Sure.
Our hub. This is what our hub looks like. It's this device has a power input. It has 10 ports. Each port is a 100 watt Class 2 certified by UL power supply, and then obviously we're also injecting the network onto these ports so that we can communicate with all the devices that are connected to us. On this hub, this is a beautiful board here, is our software running on the compute engine that does all the work of managing the system and discovering devices, implementing the provisioning. Everything that the system has to do runs on the software that we run on this hub. This is the on-premises portion of our system that is always on 24/7, 52. That is the high reliability device. And but we don't imagine we're going to write all the software on this. So just like on your phone, you can install an app that might be better than what Apple put on the phone for a calculator. You can put your own calculator app on. We imagine the same thing here. Like when we do HVAC control, I think we understand the basics of how HVAC control works, but I wouldn't say that we are the world's experts in it. So you can very easily imagine how nice it would be if the APIs are available. So a third party who really does understand the dynamics of how to do HVAC control could come in and write the software to talk to those APIs and run on our platform. So we have a place to put software on the hub that can run ever present in the building, having access to all the APIs for all the devices, so it can do the kind of things that a system like this should be able to do. We shouldn't have to write all that software. We were big believers in open systems, and only by treating this as an open system can we see that kind of future. The same thing is true in our cloud. So all these hubs talk over their internet connection to our cloud, where the cloud aggregates all the hubs for a building into a single view of how the building is operating. All the data is collected, put into a data warehouse, so we can have analytics to give the building operator insights into how the building is performing. There also is a set of APIs that can be integrated with to run applications on the cloud side. To integrate with, say, existing building management systems or third-party systems for whatever's necessary. We can't possibly sit here and say we know everything you're ever going to want to do with the data. So we create a mechanism for managing that data and securing it, and then providing APIs that can allow authorized applications to access it.
That sounds so fun. I'm a geek for these kind of things, and I'm a software developer. So one day, I promise I will play with your API.
Your C++ skills. We could use some help.
I actually program in C++, and C#. Yeah,
we'll talk.
For sure. At least for fun. Give me access for fun on a house with a camera that I can see how I can automate things there. Oh yeah, man, that would be super fun. Yeah. All right. I know you're a busy guy, so I don't want to take more of your time. Thanks very much for all the incredible experiences, information about Domatic, everything. This was so much fun, and your life is so fascinating.
Okay, it's my pleasure.
All right. Bye-bye.
Bye.
Thanks to our listeners. If you like this content, you can find past and upcoming episodes in ascworks.everse.com and at all of our Everse social media. We'd love to hear from you and recommendations for new content, so leave us a DM and we'll make sure to catch it.